Good afternoon, everybody. Welcome back to Lecture Room 1. It's my pleasure to introduce Steve Nichols, G0KYA, who's going to talk to us about Solar Cycle 25, its predictions versus reality. So the talk's going to look at Solar Cycle 25, how it's panned out, what we've learnt, and what the highlights have been so far. So Steve G0KYA is the chairman of our Propagation Studies Committee. His main interests lie in HF and HF propagation tools. So over to you, Steve. Thank you very much.
Thank you very much. Well, we're going to have a look at what the scientists said we might get for Solar Cycle 25 and compare that with what we actually got. And we'll see how good the scientists were. Not very good at all. And then we'll have a look at some other propagation tools. And also, we'll look at where we are in the cycle, or where we think we are in the cycle now. So I'm going to start straight away, so we mustn't overrun, I've been told. So here's where we are. This is the cycle 25, according to the 10.7 centimeter radio flux progression. There's two ways of measuring sunspots, basically. You either measure the radio coming off the sun at a wavelength of 10.7 centimeters, and we call that the solar flux index, or we count the sunspots. But that gets confusing because if you have one spot, that's one sunspot in one group, so you instantly have a sunspot number of 11, even though you've only got one sunspot. So it doesn't, I don't think it really tells the truth. But the solar flux index, is, for me, is a better way of doing it. But as you can see, we had Solar Cycle 24, which peaked in 2014. And you'll also notice there's a double hump on Solar Cycle 24. Which is not unusual. Normally what happens is you get a maximum in one hemisphere of the sun and then a maximum in the other hemisphere of the sun. So it's usually double peaked. So if you look at where we are now, is that the second peak or is that the first peak? Hard to say. We'll have to see. And if we look at this under the sunspot number, it's a very similar diagram. It doesn't really change that much. But you can see that we've already had a sunspot number in excess of 200 on cycle 25, and currently 150 or thereabouts. And again, you can just about see there was a double peak in 24. So again, have we got that double peak in 25? Have we had that yet? So there we go. So what did they say? Well, the official line from the NOAA/NASA Solar Cycle 25 prediction panel was that it would peak in July 2025. With a maximum sunspot count of 115, plus or minus 10, and the current behavior of the sun is consistent with early onset near the beginning of our predicted range. It says if the current trends hold, Solar Cycle 25 should peak as early as 2024, and it should be similar in strength to the relatively weak signal that has preceded it. Okay. And this is one of the diagrams that was used at the time to demonstrate that. So we had cycle 21, 22, 23, 24, all decreasing strength cycles, to be honest. And again, you can see the double peak in each of those, which suggests that this is a thing that we can look for. And this was suggesting that Solar Cycle 25 would be around about similar to 24, but maybe a little bit lower. It wasn't a very good prediction, to be honest. And it would be peaking around about now, actually, October 2024. Then, there we go. So cycle 25 will be slightly weaker than cycle 24, making it the weakest cycle on record. Boo. Weak cycles are preceded by long extended minima. This is all very negative stuff. We're currently beginning with cycle 24 in the midst of our modern Gleisberg cycle minimum. And so it was a question of, was this going to be the start of a longer minimum, like a Maunder minimum, or was it just a modern minimum? But this was what NASA and NOAA, this is not just one person's idea, this was the collective idea of what it was going to be like. This was another prediction that came about. We predict the maximum of Solar Cycle 25 will be in the year 2023, so February, March 2023, with a peak sunspot number of 154. Which would have been more than cycle 24, but not phenomenally more. This was great. Livingston and Penn showed that the sunspot magnetic field was getting weaker, and if the field drops below 1500 Gauss, sunspots cannot form. So was this going to be the start of a Maunder minimum coming up? But in the same year, this report came out. It said astronomers just measured the strongest magnetic field ever seen on the sun. So are you with me? At the moment, this just shows you that a lot of the time we don't really know. We can only report what we see, but trying to guess what's going to happen is just that, I think. This was something that Carl Litchelswab, K9LA, prepared, which was a list of 27 predictions for cycle 25. And it's only the two at the bottom there which predicted that it would actually be better than cycle 24. So out of 27, 25 of the predictions were that it wouldn't be quite so good. And this is graphically where it was. So an average cycle was there. The 2 or 3 predictions that said it would be better, and then the rest were pretty much saying, no, it's not going to be good at all. So it wasn't a good sort of forecast, I think, for cycle 24. Cycle 25. And thanks to Carl, K9LA, who is an associate member of the Propagation Studies Committee. So even though he's in the States, we still correspond, and that's why I used his data today. Now, one prediction said that we would have a massive solar maximum. This was Dr. Scott McIntosh. He's a Scot, but living in America. And his colleagues predicted that solar cycle 25 would be one of the strongest ever recorded, with a peak sunspot number of 184, somewhere between late 23 and mid-2024. And this is based on an idea an early terminator in the historical record indicates a stronger cycle. Now, this idea of a terminator, I don't know if you know, but sunspots tend to start higher up in the hemisphere of the sun. So they start at a high latitude and work their way down until they get to the middle, near the solar equator, and then the whole process reverts and starts again. So he put his neck on the block, really, and came out with this. He did revise it slightly downwards, slightly after solar cycle 25 started, but he was the only person, I think, or one of the only people who was prepared to put his neck on the block and say, no, I think it's going to be better. And I think this sums it up, really. This is Niels Bohr, nuclear physicist and Nobel Prize winner. Prediction is very difficult, especially about the future. Yeah. So I think it's very easy to look back and criticize people, but it is very difficult to predict what's going to happen. But, as I said, Scott McIntosh was prepared to put his head on the block and suggest that we were going to have a pretty good solar cycle 25. He's now left academia, by the way, and has joined a company called Linka, I think it's called, and they're a space weather forecasting company, and he's vice president there. So he's left academia, but still very much involved in space weather. So, as I said, the sunspots on the sun tend to peak in one hemisphere rather than the other. And this was a shot from a couple of days ago. And they've nearly all been in the southern hemisphere in the last few months. And as you can see, that's 3848, the one there, is pretty much near the solar equator. So does this mean that we are heading towards solar maximum, or we've gone past solar maximum? Well, this is a question that you can't really answer for about 7 months until after you've passed solar maximum. But Scott McIntosh, I saw a presentation he gave recently when he suggested that we may have hit solar maximum in about April or May. But it will be quite a few months yet before we can actually confirm that. So I said in 2019, actually it was here I think, what could we expect? Well, I said the good will have increased maximum usable frequencies, the upper HF bands will be open to DX, bands will open later, fewer coronal hole issues, more long path openings, and 6 meter band would be open. Almost there, not 6 meter band open, no, not really. I was talking to Chris Deacon yesterday, and he said there hadn't been that many 6 meter openings from the UK, but we live in hope. No, they're not so good. This is the boo side. Increased number of solar flares, increased number of CMEs and auroral events, absorption on lower HF bands, coronal holes will increase after maximum, and 40, 80 and 160 meters would not be so good due to D-layer absorption. That was my prediction in 2019, and I don't think it's got it that far wrong, to be honest. I think that sums up what we have had. But we'll look at that in a minute. So where are we in solar cycle 25? Well, solar cycle 24 declined more quickly than was forecast, and cycle 25 started in December 2019. And as I said, solar maximum is defined by the peak of the 13-month smooth sunspot number, or SFI curve. So we won't be able to actually say that we have hit maximum for a few months or until we're past it. So NOAA said that they thought we'd have maximum between July 2024 and January 2025. So in other words, we are somewhere around maximum now. And what does this mean? Well, if you really want to know what it means that conditions are going to get worse. Because on the whole, you get more coronal mass ejections, more solar flares, and other problems on the downward portion of the cycle, not on the upward portion of the cycle. And so another view was that it was the maximum was somewhere between January and October. So I think we either are near maximum or have just passed maximum, but we'll have to see. This was another graph that was prepared by Carl K9LA, Carl Nichols swab in the States, and this shows you the smallest cycle, cycle 24, the maximum of cycles 23, 21 and 19, which was 1958. That was a really, really big cycle. And you can see that we are the red line on there, so we're cycle 25 in progress. So yes, we have had a better cycle than cycle 24, the last one, but it hasn't been massive. It's not been a record breaker, and it's not even been that phenomenal. You know, the solar flux index every now and again over the last few months has been very, very good. But don't kid yourself, it's not been a 1958 breaker, you know, a world record breaker. But we live in hope. You never know, it might get a bit higher. We'll see. It's got to go a long way to break 1958's record, though, I think. So how will propagation improve? I heard people saying this recently, oh, conditions are really rotten, they're terrible. Well, I think a lot of it has been the time of year. HF propagation in the summer is never particularly good, other than sporadic E, which is, well, nothing to do with sunspots, to be honest. But this is a VOACAP chart showing propagation between the UK and New York from August and August 2024 on the left, and October 2024 on the right. And as you can see, the MUFs are much, much higher from August to October. So in other words, in August, if you look at that, chances are you definitely work at New York, maybe definitely 20 meters, definitely 17 meters, and maybe the odds of a 15-meter opening, but no 10-meter openings whatsoever. But jump forward to October with the same smooth sunspot number, or near enough, and yes, now you can see that we've got 28 megs is open, roughly from midday to 6 o'clock. And these charts, this is voacap.com, so you can all go on there and produce these sort of charts if you really want. But it just shows that I think when people say conditions have not been that good, I think you have to take into effect the summer doldrums, as we call them, on HF. And so we're now seeing, when there are no coronal mass ejections and no solar flares, we do begin to see 10 meters really, really opening up. And this is a damn good month for it. So if we should get a few days where the K index will stay low, we should see some really, really good 10-meter propagation. And hopefully this will now, well, probably extend the whole of next year, probably, and maybe the year after that before it starts to die down again. So yes, over the next year, work your DX, because it's going to be probably about as good as it gets. Now, the big Aurora event of May the 10th and 11th, 2024. I wrote this script for GB2RS on the Thursday before that happened, and I said there have been 4 X-class solar flare events on May the 8th and the 9th, which have prompted CMEs, which could join together to impact the Earth this weekend. We can expect a strong G3 event, perhaps on Saturday, with the KB index rising to 6 and the potential for visible aurora in the UK. So, got it half right. We did have visible aurora in the UK. It didn't go to 6, it went to 9. And we had a very, very strong geomagnetic effect and geomagnetic event. How strong was it? Well, this is the KP index chart on the right there, which it neared 9. I remember that was, what's that? It was, yeah, about just before 9 o'clock, that one. And I remember looking at that thinking, oh, crikey, that's gone up a long way. Should really go out and see if there's any aurora, but no, I can't be bothered, I'll go to bed. And woke up the next day to all these marvelous pictures. And you can see here on the left, the auroral oval has come down. I can't remember I think if we can see Great Britain is there. So we're right under the auroral oval, which explains a lot. So that was a pretty fantastic event. And I'll show you the effect that it had on the MUF. This was PropQuest's critical frequency plot, an MUF plot, for the day before this auroral event. And as you can see, the MUF over 3,000 kilometers was in excess of 21 megahertz. Now, what does it look like the next day? Yeah, basically nothing. You know, the digisondes, or the Daub digisonde, was not recording anything coming back from the ionosphere at all. And it took until 4 o'clock in the afternoon, or 4 or 5 o'clock in the afternoon, before the ionosphere even started to send any signals back. So yeah, I think that's a classic example of what a geomagnetic storm does to propagation. That was the scene from Quebec, which is very pretty. This was the scene from Norfolk, Roberts G4T UK's location. But of course, someone said to me, well, do you think this will happen again? I said, well, probably will, but quite when, I don't know. Well, as you probably know, yes, it just did. We just had it again. So this was 2 days ago. And this was by Magda, who's the wife of G4BAO's builder. A Polish lady who shot this in Cambridgeshire 2 nights ago, I think. And I thought, well, we'll put that in. I think it's a good shot. Good shot. So yes, so we've had lots and lots of aurora. I'm not that interested in aurora, but I am interested in HF propagation, which has been dire as a result. The two tend to go hand in hand. So while HF propagation was badly affected in May, it was better news on 6 and 2. And on 6 meters and above, it seems there is too much auroral spread for FT8 and FT4 to work. But Tim M0AFJ reported that 2 meters was full of auroral CW. And David G3WGN, he worked Netherlands, Germany, Hungary. What's S50? That's Slovenia? Slovenia, Yugoslavia? No, it can't be. Romania. Thank you very much. Anyway, lots of places on 2 meter CW. 2 meters was good. Yeah. And apparently it was good the other night as well. So while people are out there watching the aurora, they could have been working DX. But while HF people were just crying into their soup or whatever. So let's think about this. What have been some of the highlights of the last year? I just picked 3 or 4 contacts that I just thought were a good evidence of excellent propagation. So this was VK9DX Norfolk Island on 10 meter USB. SFI at that point was 245, the KP index of 2.5. Well, anything below about 3 is good. If you have 2 or 3 days of a low KP index, you tend to get better propagation. So the chart on the right is a VOCAP chart of the path from the UK to Norfolk Island in the Pacific. And I've put a line on there just before 10 o'clock. So you can see that the prediction was that 10 meters should be open, just be opening up to Norfolk Island. And they were allowed for hours, actually. It's very good, which just shows you what you can do with a good SFI number, low KP index, and good HF conditions. This similar one here was St. Paul Island, which is a recent de-expedition. The reason I put this on, I worked them on FT8, but that wasn't really what took my or made it rare. What made it very good was this path on 10 meters, not 12 meters here, but 10 meters, was still open 2 hours after sunset, which was fantastic. It's not often you hear 10 meters still open after dark, but it was. And if we plot it out on the right-hand side with VOACAP, you can see that suggestion is that there should be some 10-meter openings at that point, but it obviously tails off as the evening goes on. But I do remember listening, thinking, "Well, that's good. I can still hear it. What's going on?" And just 2 more contacts, really. I maintain the 10-meter beacon list for RSGB. We'll talk about that in a minute, but just little beacons that run very little power. This was the 5-watt beacon in Illinois, NS9RC. And yeah, you could hear it very easily and for hours on end, which tells me that 10 meters is really working when you can hear American beacons running 3 or 4 watts. And it's nice to contact these people and say, "Hey, you've just been heard in the UK," and people get a real thrill out of it. But everyone to each his own. But I do think that hearing a 3-watt beacon out of America is still magical. So that's my particular level of interest. And again, if we look at the VOACAP chart for that, we can see that the 28 megs should be open. I mean, North America in October should be really good on 10 meters. So again, if you have 2 or 3 days with a low KP index, no solar flares, no coronal mass ejections, no aurora, we should get some good 10-meter propagation again. And just one more here, a 4-watt beacon, North Carolina. This guy was very pleased to hear that his beacon was being picked up. And again, the chart shows you that yes, it should be possible at 28 megs, or even a bit higher actually. But we certainly haven't got any 6-meter propagation of any great record anyway. Whether we will get some, I don't know. SFI 245 there, it's not going to get much higher than that, I don't think. Maybe maximum 300, but we may have already gone past the maximum, so who knows. And this last one was Vietnam, which I worked the other day on FT8. Why did I work on FT8? Well, because that's what he was on. I would have had a debate about this with somebody last night. Well, I wouldn't have worked him. If he can't go on CW, I wouldn't have worked him. Well, he didn't want to be on CW, he wanted to be on FT8, so I worked him. Tony. That's 2 people here around who think like that. But yeah, I saw him pop up on was it WSJT, and I thought, oh, Vietnam, that's interesting. So put a call in, yeah, it came straight back. So that's the sort of thing you can do on 10 meters when conditions are good. So again, SFI was 245 at that point. So it's nice to make the contact anyway. And as you can see from that chart on the right, the fact it goes up and above shows you the MUF over that path was probably more like 35, by 40 megahertz probably. So I think that there is the odd 40 megs beacon, isn't there? Where is there? Is there one still? I think, is there one at Camp Cornwall? Have they got one?
They've gone down on the US licenses.
Yeah. But there are some 40-meter beacons available, and I wouldn't be surprised if you start hearing them, over time as well. How are we doing for time talking of that? Oh, we've got 20 minutes yet. So what can we expect for the rest of the cycle? Well, this is a chart of sunspot number and disturbed days. And lo and behold, you can see that the two really go hand in hand. You can't have one without the other. It's just one of those things. But what you also notice is that on the downward slope of the cycle, you tend to have more disturbed days. So this probably means, and here we go, that the next 6 months may be even worse than we have had recently for solar flares, coronal mass ejections, and aurora. Now, whether that's good or bad depends on what your particular interest is. If you're a 2 meter and 50 megahertz auroral devotee, then you'll be absolutely laughing your head off. if you like seeing visible aurora in the UK, you'll be laughing your head off. If you like working DX on 10 meters or HF in general, you won't be so happy. But there we go. I would say we've got, as I said, at least 12 months of good conditions yet, maybe 24 months. But we're probably either at or have passed sunspot maximum now. So there we go. If you don't get on now, you'll miss it. And you have to wait another 11 years, won't you? So, as I said, we should have good DX for at least another year or two. October's probably one of the best months for DX. 10 meter DX generally needs an SFI greater than 100, but geomagnetic disturbances are generally worse on the downward portion of the cycle. And will we get another major auroral event? I've said possibly, more likely probably. Whether we'll get another one as good as May, I don't know, but then the other one that was 2 days ago was not far off, I don't think. You just need a number of things to happen at once. You need to have a very big solar flare with a big CME. It has to have the BZ, it's frozen in magnetic field, which is what happens you get with plasma, that has to be pointing south. Now we talk about the BZ pointing south, and I sometimes wonder whether people actually understand this, but when this solar flare throws off this, well, not the solar flare, when the coronal mass ejection throws off this plasma, it has a frozen-in magnetic field. And if that magnetic field points south, it's a bit like a bar magnet. You know, if you have a north-facing bar magnet and a south-facing bar magnet, they will join together. And that more easily couples with the Earth's magnetic field, and the plasma comes flooding in. If they're both pointing north, it tends to bounce off. So if you have a BZ which is pointing very strongly south, look out for lumps. That's when the problem starts. No, just one other thing. The 10-meter beacon list that RSGB runs has been revamped. It was originally produced by Martin, G3 USF, and we kind of maintained it for about 5 years. But this last year, I just decided, no, it's just so out of date, it's terrible. So I scrapped the whole thing, and we started to use the reverse beacon network to regenerate the list. And so the beacon list is brand new, it's up to date, it's pretty much there. I've got to put some updates in, I think 5 or 6 updates in very soon. But if you use the RBN to do this, it's producing about 50 to 100 spots per minute. And so what I have to do is have the beacon list there and the RBN list there, and you compare the two. And every now and again you'll see a new beacon that's gone up. But if anyone wants to help doing that, then they're quite welcome to try it. And if you find a beacon that you're hearing that's not on the list, then just send me an email to PSC Chairman. I'll show you the email address at the end, and we'll get it updated. And finally then, just some other tools that we can talk about. I mean, do you know that we have now a VOACAP RADCOM chart? Do you know that the listings in RADCOM, which are for HF, well, we've replicated that on VOACAP, and we've replicated that on a program called ITU RHF Prop, which we've changed to Proppy because it's easier to pronounce and remember. So if you want your own personal chart of the RSGB locations that you can work, you either go to rsgb.org/proppy or rsgb.org/voacap, and it will prompt you for your station in terms of your antennas, the altitude, the noise level at your location, and then you can print out the colored charts for your particular station for the next month. We always have to keep telling people this because people forget. So that's the two main RSGB propagation listings that we've got. This is another one that I've generated some time ago, which is g0kya.blogspot.com, and on there you've got a short path propagation from the UK, just a small, very small map that you just click on the month that you want, you select the band and the time in UTC, and it will come up with a chart like this that shows you where you like to be or where you like to hear things. it's just a very, very quick and easy way of seeing what's open from your QTH. Also on there now we've got some of the information that's been duplicated from spaceweather.com. And you've got this other chart in the middle there, which is the magnetic field of or BZ component. So you can see when it goes the left hand, I've just got a point here, this left hand one there, when that points south, that means it's more likely to couple with the Earth's magnetic field and we're going to have more effects. And the speed of the solar wind, it's showing there 600 kilometers per second. Which is, it's normally about 400, so that's an enhanced solar wind. But it's kind of neutral or pointing north, so it wouldn't be a big problem. When that thing swings deeply south and the speed goes up, you know you've got problems. And then we've got the KP index on the bottom as well. So it's just another little tool that you can see, and it's just, I think graphically it's better than reading about where the BZ is and how many nanoteslas. I banned the term nanotesla from GB2RS because we used to say things like, oh, the BZ has gone south and is now at 200 nanoteslas or whatever. And everyone was going, is that good or bad? I don't know, what does that mean? So I banned the term nanotesla from GB2RS, so we now talk about, the BZ is pointing south, which is not good because it means, this, that and the other. So there we go. So any more details, as I said, if you want to take part in that beacon listing and keeping that up to date for us, feel free. I do it about once every sort of 2 months, spend a whole day on it, just watching the things scrolling by and checking them on the list. But if you are really bored, and there's no Aurora to look at, mind you, and no DX to work, then feel free to join in. So you can send your details to psc.chairman@rsgb.org. And then we've got rsgb.org vocap and rsgb.propy. The difference between those is that vocap has been a propagation prediction program that's been in place for some time now, and the ITU came up with a new version of, based on their models of the ionosphere, and it was called ITU RHF prop, or propy as we call it. So if you can choose which one you want. I mean, we decided in the end to have both the vocap and propy predictions available, and you'll see that on the whole they're both kind of the same sort of similar conditions anyway. But Gwyn Williams, who produces the propagation predictions for Radcom, swears that ITU RHF prop is more accurate than vocap. But you can take your choice of which one you use. And thank you very much for your time. And we'll go to any questions now. I've got 10 minutes left anyway. Right, we've got to...
Am I right to ask? Steve, where exactly on your blog is the prediction? I've just looked and I can't see it, I'm afraid.
You got, sorry, what?
You said on your blog page there's those charts that you just showed
Oh,
us.
right, on the top right, top right, there should be a link from, you can't see it? I can't see it from here. Hang on, right, so scroll down. Oh, it's probably, I know what it's doing, it's reforming it for a phone, isn't it? Should we try and look at it on here? Would that be easier?
Yeah, that'd be great.
Yeah, okay, hang on. Bear with, as they say.
Whoops, typo.
Oh, right, okay.
It was also filling, I think, the correct thing for you.
There we go. So you've got this one here, and you just click on that now. There we are. So we'll pick October, and it automatically uses the correct sunspot number or smooth sunspot number for that month. And then, let's see, 2 o'clock, let's put it on 10 meters. So this shows you the likely areas you are able to work on each band. So if we put it on 3.5 megas, that will shrink dramatically. There we go. And 7 will get a bit bigger, 30 meters, etc., etc. And 20 meters gives you, oh, look at that, you probably still work New Zealand this afternoon at that time. So it's a vocab-based program that just quickly gives you a load of charts that you can go through. But as you say, if that's October, but go back to August, this was people saying, oh, conditions have been rotten. Well, yeah, they will be. Actually, if we go to 10, it'll be even worse. Yeah, so August you could work north-south, not a bad month at all for north-south. But yeah, work in the States, it really doesn't kick in on 10 meters until you get to October again. Let's go to October. There we are. And so if we now just advance that a little bit, it's now coming in the eastern seaboard, nice and red. And on a good day, in October, you should be able to work the west coast if you've got a decent antenna and a bit of power, maybe, on 10 meters. Yeah, so we go to 15. Oh, yeah, we are on 15, not 10. There we go. Yeah, and it goes south then. There we go. That's better. Yeah. And so here's the charts I was talking about. So the BZ is just pointing south there, but the solar wind speed is quite low. So I wouldn't expect KP index to be that bad at the moment. And it isn't. Look, it's down here. It's sort of 1 or 2. So, yeah, by the time you get home tonight, you probably have some good HF conditions. Yeah.
Quick question, please. How quickly can the SFI index change? If it's high on a Tuesday, will it still be high on a Wednesday or a Thursday?
That's a good.
How long does it take to decay?
That's not a bad question, actually. It can probably stay quite high. I mean, it is the instantaneous measurement of the radio noise coming off the sun at 10.7 centimeters. So if it's high one day, it's probably going to be in that kind of region the next day. Now and again, they will take a reading just as a solar flare has gone off. So the SFI will look like it's 400 or something. And sometimes they have to throw that one away, but it's just the exact time they've taken it. And I think we had a case recently where it was something like 400. And they said, well, no, it's not. No, it's not. It happened that just there was a solar flare at that point, and the noise just boosted it up. But yeah, I think at the moment we're in that point in the solar cycle where it's going to be high-ish, but also the sun is rotating. So a lot of the sunspots, active sunspots, are moving off, and there might be something coming around the corner. I mean, again, we use solar ham an awful lot. You've just raised a good point. Is GB2RS, that's prepared on. Well, Jim does his bit on Wednesday night, don't you? I do my bit on Thursday morning. That then has to go to RSGB, who then compile it, send it on Friday, and it's read out on Sunday. So I'm writing something on a Thursday that's going to be read on Sunday, but it's going to be talking about the next week. So trying to get it right is very hard. And if we look at this picture here, from that, it doesn't look like there's an awful lot coming around the corner. So from that, would you deduce that the SFI is going to go down? Probably. The SFI will go down a bit next week. So we use that. We use the pictures. We use other information like the NOAA homepage. So if we go to the Space Weather Prediction Center and look at their forecast for next week, I think it will suggest, what's the date today? It's the 13th, isn't it? So there we go, 225, it's 235 today, and it'll drop down to 175, 170. So the SFI is going to go down next week. But this is what gets me. They don't give you any indication of what's happening geomagnetically. They put the solar flux index is 175, KP index at 2. Yeah, it'll take one CME, or one flare and one CME, to completely ruin that. So it's a little bit like this, really. It's guessing, a guessing game. But we do our best. That's the best we can do. So, yeah, there we go.
Hi, Steve. Thanks.
Hi.
Very interesting. Why don't we get reliable predictions for 160 and 80 meters?
160 is that enigma that is very difficult. If you read any of the books on 160 meter propagation, it's a very, very difficult band to get predictions for. You might get really good conditions one night, but not the next, but you can't actually say, well, what caused that? You could say, well, actually, any solar flux index is bad for 160 meters. You could say any geomagnetic disturbance is bad for 160, but it's really, really hard to predict good 160 meter propagation. Other than December is a good month, we can get it to that point. Must have a dark path between them, but much beyond that, it's very hard to predict. Honestly. Yeah. Hello.
ON4UN's book has some interesting comments about trying to predict propagation on top band. So the question I have is, if I remember correctly, at or near sunspot maximum, the sun's magnetic poles flip.
Correct.
Has that happened yet? Because that might be also a good indication to correlate with.
That would be a good. I don't think I've read anything that says they're flipped yet.
Okay.
But you're absolutely right. There isn't actually an 11-year sunspot cycle. It's a 22-year sunspot cycle. Exactly. And yeah, the magnetic field flips, or more to the point, the sunspot number, the sunspots themselves, the field flips. But as I said, they start off at high latitudes and work their way towards the equator.
They show these butterfly diagrams, as they call them.
Yes, exactly. But it's not looking too good, I don't think, if we're on the downward side, which may be why we're having these aurora now.
Right.
I'd stick my neck on the block and say it's we're either at maximum now, or maybe we passed it by a few months, but we'll have to see. Ask me in a year.
Okay. The other thing I was going to give a shout out, just in case people don't know about this, but on YouTube there's a channel run by a lady called Tamitha Skov.
Tamitha Skov, yes, Space Weather Woman.
Yes, and she does some excellent presentations about current conditions and predictions.
Yes,
and generally they're very current.
Yes.
So if you want to get some very good up-to-date information, that's a good source.
Yeah, she's in the same boat we're all in, though, that she's, saying what's happening now, and trying to guess what's happening over the next 2 days or so. I mean, we're getting better at it. If we know there's been a solar flare, the likelihood is there's been a CME with it. If the sunspot was pretty much square onto the Earth, you can guarantee that's going to head our way, and then we kind of work out the speeds.
Wait about two
or 3 days. Yeah. But to say, oh yes, it will hit at 9 o'clock or whatever, it's tricky. It's tricky. Okay. Yes, sir.
Quick question. I thought there were now more satellites.
I can't hear you. Sorry.
We can't hear you. I'm only getting ground wave.
Yeah.
Quick question.
Oh, yes.
I thought there were now more satellites revolving round the sun, so we could look round the backside of the sun and see sunspots
stereo.
coming
You're
out.
talking about the stereo satellites. Stereo ahead and stereo behind. Unfortunately, stereo behind, I think, failed. So we've only got stereo ahead, which is not much use. Well, I don't know. Well, it's better than nothing. But yeah, if we look on here, you'll see you can actually select stereo, I think. Where are they? There we are, stereo. And search for stereo images. They don't even put them up now. Look, you have to find them. Stereo ahead, and then you can choose extreme ultraviolet light. Oh, yeah, put a star. Oh, damn! You can't just get it. You have to, put your times in. But yeah, that's the only ones we've got at the moment. But one of them's broken anyway, so it's tricky. Yeah, and you have to not just look at sunspots in available light. You have to look in extreme ultraviolet as well to look for things called coronal holes, which are areas on the sun which are of lower energy, which have open magnetic field lines. So you don't just have to have a solar flare and CME to get problems. You could have a coronal hole, which lets the solar plasma flood out, and that will put the K index up as well. So yeah, there's a lot of things to look for. Good. I think we're just about done now. So any more questions? No, you've all had enough.
That's great then, Steve. Thank you very much for your talk. We show our appreciation, please, everybody.